Okay, Ruben, thank you. So, we have exam coming up on next week, formative. So probably the most important thing to talk about is the cheat sheets. So I'm going to let you guys take in your geometry A3 page and then two A4 pages of notes. Okay, so whether that means you just stick the other two cheat sheets together is probably the simplest thing. Okay, so what does that mean? That means your A3 for your geometry test, you're allowed to take in an A3 page that I've printed the theorems onto. Okay, so you can take that, and then you've got two single-sided pages of A4 notes or one double-sided. Okay? Question? Yes. Yeah, I can do that. Yep. Okay, so what I've handed out here, what we're going to do, we've got 3 lessons, right? So today we're going to go through sequences and series. We did that right at the start of this semester, so it's a long way from your brain. It's a long way from my brain as well. I'm going to try go through some of these problems with you guys today. So it's going to be a bit of a test to me. I haven't really looked at it yet. I've just copied and pasted these general notes from our notes booklet. Now when we did this was done from the yellow, Brad. When we did this was done from the yellow textbook. Okay, so in a moment, not yet, like we'll go through some stuff first, but you can go get it if you like, and you could go get your notes book that has all of the stuff from sequences and series in there as well. So let's just have a read through of those dot points. Number sequence is an ordered list of numbers defined by some rule. We looked at 2 types. We looked at arithmetic, okay, where the difference was the same. It was going up or down by the same amount each time. And then geometric, where it was going up or down by the same product each time, going up or dividing by the same number. And then we have the rules for the general term for a arithmetic sequence, the general term for a geometric sequence. So that's what a sequence is, okay? It's a list of numbers. And then we have a series, which is when we're adding that list of numbers together. Okay, so we had arithmetic series and we had geometric series as well. And then there's some formulas there dictating that. We had finite geometric series and infinite geometric series that converge if the rate is between -1 and 1. The rate at which, the ratio, we call it the common ratio. Okay, so let's get into some of these. We've got this number sequence here, 5, 9, 11, 12, 15, and 19. Okay, and it's not arithmetic because the difference is not always the same. See, here it's gone up by 2, here it's gone up by 2, but then it's gone up by 1, and then it's gone up by 3. So it's not always going up by the same amount, and it's not multiplying by the same amount either. So it's not going up by some product. So it's not arithmetic, it's not geometric, but this is the sequence we're given. Consider the number sequence, find T2. Okay, this means state the second term of the sequence. Term that belongs in the second position is 9. Okay, T2 is 9. I'm sorry, I said that was a difference of 2, that's a difference of 4. Sorry about that. Part B, find T6. The 6th term of the sequence, okay, is 19. And then S4 means the sum of the first 4 members of the sequence. So we have 5 plus 9, 14, plus 11, 25, plus 12, 37. Okay, so just getting familiar with some of that terminology. Identify the following sequences as arithmetic, geometric, or neither. So let's look at the first one there. We've got 7, minus 1, minus 9, and minus 17. Okay? And we have to try and pinpoint what is it going up or down by each time. So we can see here we've gone down 8, take 8, take 8. So it's going down by 8 each time because it has the same difference, same common difference, we call that. It's an arithmetic sequence. Okay? Maybe for that one, because I'm not seeing it pop up here elsewhere, let's come up with the general term for it. So the general term, we're going to use that first formula that we've got there. That's Tn is T1 plus n take 1 times d. Okay, so the nth term, okay, we could find the 50th term or the 100th term. It's going to be the first term plus n take 1 times the common difference. So T1 is 7, and we have n take 1 times, the difference is minus 8, and we can expand and simplify that there. What are we going to have? We're going to have 7 take 8n plus 8. We've got 15 take 8n. Okay? And so now we can find any term of the sequence. This is where you also do stuff like, I'll just do a quick recap. It'll say something like, when does the sequence get below minus 50? Okay, for what value of n is the sequence below minus 50? And so that's when you go, 15 take 8n, when's it going to equal minus 50? And then we solve for n such that what is the nth term that is below minus 50? Okay, so that's where we're doing that kind of stuff there. Maybe I'll perform that one with you guys now, just in case there's a few confused faces. So that is a question like this. When does the sequence reach a result, or a term, I should say, reach a term below minus 50? Okay, and just in terms of like the number line, okay, here's 0, here's minus 50. Below minus 50 means to the left of minus 50. Okay, so it has to be more negative than minus 50, like minus 51. So that's what we're going to solve. We're going to solve 15 take 8n equals minus 50. It's a linear equation. We're going to isolate n by itself, subtract 15 from both sides, and we have minus 8n equals minus 65. Okay. Now, I'll just explain what my thinking here. Like, we could perform that in our calculator, but I know when I divide both sides by minus 8, I'm going to have n is minus 65 on minus 8, which is positive 65 on 8. That is, it's 64 divided by 8, and then 1 on 8, isn't it? So we know 64 divided by 8 is 8, so it's going to be something just over 8. Okay, you can perform that in your calculator, but it's going to be like 8.125, I think. And so what that means is the eighth term is going to be above minus 50, and the next term in the sequence, which is the 9th term, is going to be after minus 50. Okay, so therefore, to answer this problem, when does the sequence reach a term below minus 50? The nth term, the 9th term, sorry, is below minus 50. Okay? And how would we calculate the 9th term? Well, that's when you put the number 9 into this equation. Okay? So let's do that. Like, if we were to find the 9th term, T9, that's going to be 15 take 8 times 9. All right, what's that? 15 take 9, 8, 72. Okay, you can see we're negative 60, 72, 15. What's that? Negative 57. Okay. Okay, moving on. Let's. So the next one would be a geometric sequence. Maybe I'll go through that one quickly to remind you guys of that one. We've got 4, minus 2, 1, and minus half. So 4, minus 2, 1, and minus half. And so what we can see is it's dividing it by minus 2 each time. Dividing it by minus 2. Or we need to think of a geometric sequence we're multiplying. So what are we doing? We're multiplying it by minus half. Okay? So if we have 4 times minus half is minus 2. Minus 2 times minus half is positive 1, times minus half is negative half. Okay, so it's a geometric sequence because it has the same ratio, not the same difference, not going down by the same amount or up by the same amount. It's got the same product each time. Okay, so for a geometric sequence, the formula is T1 times R to the power of n take 1. Okay, so this is going to be, the first term is 4. Our rate, our ratio, I should say, sorry, our ratio is minus half, and that's to the power of n take 1. Okay, so we have an nth term there for a geometric sequence. All right, and you can perform some similar processes as well. When does it reach 50? When does it go over 1,000, etc. Okay, let's move on to 3. I might give this a bit clearer up here. Now, if you want me to pause or ask a question at any stage, please tell me.
We should make a Spec next semester. You're gone.
Okay, so what are we up to? Find k if 3k, k take 2, and k plus 7 are consecutive terms of an arithmetic sequence. So that means this is the first term, this is the second term, this is the third term, okay? And there's going to be some sequence that keeps on going. It's like, well, what's the value of k? Now, if it's true that this is an arithmetic sequence, then the difference between these two is equal to the difference between these two. Okay, the difference between both of them is equal. So what does that mean? Like if this is T1, this is T2, this is T3, because the difference is the same, term 2 take term 1 is equal to term 3 take term 2. Okay, it's going up by the same amount each time. So we can come up with a nice equation about that. K take 2 take 3k equals k plus 7 take k take 2. Now this is something really, like if you're not concentrating, this is an error that pops up time and time again. It's something you see in the rest of year 11 and in year 12, is whenever you're subtracting, okay, whenever you're subtracting anything, okay, especially something with a composite amount of terms, that negative is going to distribute to both of those. So it is imperative that you put it in brackets. Because you notice if I don't have brackets there and I just go take k, take 2, you just subtracting the k and then you get the wrong answer, okay? So absolutely must have brackets here, and we're ready to collect like terms and solve this equation. K take 3k, we've got minus 2k take 2 on the left hand side. On the right hand side, we're going to have k plus 7 take, I might expand it out in between here, k plus 7 take k plus 2. Okay, k and k cancel, and then we've got 7 plus 2 is 9. Okay, we're going to rearrange this to get k by itself. We have minus 2k is 11, divide both sides by minus 2. We've got k is minus 11 on 2, minus 5.5. Okay, so, I mean, this is algebra, okay, I expect you to be able to do that. But here, what's the concept we're talking about? Well, it's an arithmetic sequence, so the common difference is the same. Term 3 take term 2 equals term 2 take term 1. Okay, if it's geometric sequence, well, term 3 divided by term 2 equals term 2 divided by term 1. All right, so that same sort of relationship holds. Okay, let's move on to 4. I mean, we've already talked about a geometric sequence, so we might skip 4. It's very similar to here. Find T1 and R. Find the 16th term. That's where you put the number 16 into the equation. Okay, let's have a go at 5, because that is a geometric sequence as well. So I think this one will challenge me a bit, because I haven't look at this. So my apologies in advance. Okay, the general term of a geometric sequence is given that it's, find the general term, given that its 6th term is 16 on 3 and its 10th term is 256 on 3. Okay, so the general term of geometric sequence is this. Tn equals T1 times R to the power of n take 1. Okay, and the pieces of information we're given are T6 is 16 on 3. Okay, so that's T1 times R to the power of, let's do it slowly. 6 take 1. So the 6th term is 16 on 3. All right, so all I've said, this is the general term. We know that we're talking about the 6th term. Okay, we're told to find the 6th term. So I've put the number 6 where n is. Okay, and what does this give us? It gives us T1 times R to the power of 5 is 16 on 3. That's our first equation. And then our second equation is the 10th term is 256 on 3. Okay. All right, and then what we'll do is, so we've got two equations, simultaneous equations, we just need to rearrange it for one variable and solve it. So for instance, let's just take the first equation here, okay, let's call them equation 1 and equation 2. So in equation 1, I've got t1 times r to the power of 5 is 16 on 3. I want to get t1 by itself. So what I'm going to do, I'm going to move it over the other side. Okay, I've got t1 by itself from the first equation, and now we're going to put that into the second equation. Okay, so we've taken the first equation, we've manipulated it to get t1 by itself. Let's put it into the second equation. We're going to have 16 on 3 times r to the 5 times by r to the 9 is 256 on 3. All right, so all I've done is substitute this here in for t1 here, and then we can simplify this and solve for r. So let's go ahead and do that. What we've got at the top is r to the power of 9 on top of r to the power of 5. So get back to index laws, r to the 9 on r to the 5, that simplifies to r to the 4. So we've got 16 on 3 r to the 4 is 256 on 3. Okay, we're looking to get r by itself. So whenever we'd say we can divide the other side by this equation, or you can think about multiplying it by the inverse. Let's multiply it by 3 on top of 16, and over here 3 on top of 16. So then what's happening here? We've got 3 at the top and bottom cancel, 16 at the top and bottom cancels. We've got r to the 4 on the left-hand side. And over here, we've got 3 at the top, 3 at the bottom cancels. We've got 256 divided by 16. What is that? 16? And then r is 2. So what's the next step? We've got r to the 4. We want to get r by itself. Okay, we can do anything as long as we do it to both sides. So the thing I've been telling people is you put 1 to the power of 4 on both sides. Okay? Because then, again, using index laws, here we've got 4 times 1 on 4, which is 4 on 4, and 16 to the power of a quarter. Now, r to the 4 on 4 is r to the 1, which is r by itself. Now, 16 to the 1 on 4, we can address that. We can break that down too. I mean, you can just punch that into your calculator. But 16 to the 1 on 4, what we can think is, like, what are powers of 16? Like, you could express it as 4 squared. Okay, or you could express it as 2 to the power of 2 squared, which is 2 to the power of 4. 16 is 2 to the power of 4. And so then over here we've got 2 to the power of 4 to the power of a quarter, it's 2. Okay, now if you had trouble following along there, look, just put 16 to the power of a quarter in your calculator, you will have it with you. Okay, so that was 5. All right, let's do 6. Okay, starting to come back a bit, I hope. Very excited. Okay, 6. Insert 6 numbers between 23 and 9 so that all 8 numbers are in arithmetic sequence. So we've got 23 and 9. So like this is term 1, and then we're going to have term 2, term 3, term 4, term 5, term 6, term 7, and then here's going to be term 8. Okay? And so, well, here there's going to be some difference, isn't there? There's going to be some difference here, and there's going to be some difference here as well. And in fact, what we can think of it is that this term is 23 plus d, this term is 23 plus 2d, 23 plus 3d, 23 plus 4d, 5d, 23 plus 6 times the difference. Okay? Yep, so we know that the difference there is the same, the difference there is the same. And so if the difference is always the same, we're not sure what the difference is yet, but we know that this term is going to be 23 plus the difference, and this term is going to be 23 plus 6 times the difference. And then, like I've said with arithmetic sequences, term 2 take term 1 equals term 3 take term 2 equals term 5 take term 4 equals this piece of information here, term 8 take term 7. Okay, so let's make that statement first. Term 2 take term 1 equals term 8 take term 7. Why am I jumping to term 8? Because that's where we're given some information. Okay? So then let's do that. We're going to have 23 plus d, take the 23, equals 9 take 23 plus 6d. And linear equation here that we're solving for d. Okay, over this side we'll have d. Over here we'll have 9 take 23 take 6d. We'll have 7d is minus 14. D is minus 2. Okay, we've got the value of minus 2, and so then we're ready to generate all of the numbers of the sequence. Okay, the difference is minus 2, so the sequence is 23, 21, 19, 17, 15, 13, 11, 9. Okay, here's the 2 numbers we're given, and then the 6 numbers in between are all in arithmetic sequence. Okay, and then let's do question 7. I think that's a pretty straightforward one, just from looking at it. Very good. An arithmetic sequence has 9 terms, so I can fit that in here, I think, pretty easily. There are 9 terms. The first term is minus 2. And the last term, so the 9th term, is 54. Find the sum of the series. So a series is when we're adding members of a sequence together. And so let's look at our dot points there. We've got the sum of a finite arithmetic series. Okay, that's the third one from the bottom. The sum of a finite arithmetic series. And we've got 2 formulas there for it. This one's the most basic, isn't it? It's n on 2 times t1 plus tn. Okay. And so we're just putting all those numbers in. So the sum of the first 9 terms, S9, is going to be 9 divided by 2 times t1 plus t9. I won't try. Work that out. 52 times 4.5. That's not that bad, is it? 234. Okay, and what's the significance of that? It's if you take the first term and the second term and the third term and you keep adding them all together, you're going to get 234. Cool. Okay, so hopefully that sort of gets the brain ticking over a little bit. I reckon, like from here, really you've got sort of free rein on how you're going to use your time, okay? As long as it's for Spec Maths revision, that's what we're doing here, Brad. So my advice would be have a look through your notes book, okay? Now, one thing I've said to you guys over and over again is it's about if you can read a process and comprehend it. What have I said? I've said you're deadly, okay? That's what we're going to do now. You're going to take your notes book, have a read through it, try and look through your working, see if you can understand what you've done, and then point out any questions you might have from it. Okay, so that'll be our first thing. And then it's just up to you. Where are you going to spend your time revising? Okay, so I do have some exam booklets here I'm going to pass out to you guys. The exam is broken up into 3 sections. It's like, here's sequences and series, here's deductive geometry, here's vectors. So you can do that if you want. And I'm sorry they printed on these like measly A4 booklets. I just forgot to press the A3 button and thought, you guys care about the environment, so you wouldn't want me to print it A3 if I've got that already. Okay, so you can do the exam. You can look at your past tests, and you can look at the review sets. Okay. So Nick, just one more thing. All the practice tests and that for this would still be attached to the assessment task on Sector, so you can access it all there. All right. So if you need to go get some stuff, you can go get it now. I'll pass out these booklets, but let's use our time effectively.